Assalamualaikum warahmatullahi wabarakatuh, brothers and sisters.
Waalaikumsalam, Dr.
Okay. Right. There are not many of us. I hope they will be joining us soon. Okay. As usual, let's start our day with the recitation of Ummul Kitab Al-Fatihah. A'udzubillahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Arrahmanirrahim. Maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Okay, let's have Ustaz Muhammad Yunus to lead the dua for us. Tafadhal Ustaz.
Bismillahirrahmanirrahim. Allahumma nawwir bil kitabi absarana washrah bihi sudurana wa sahhih bihi abnanana watliq bihi alsinatina wa qawi bihi jinanina wa asra' bihi fahmina wa qawi bihi azaimana bi hawlika wa quwwatika fa innahu la hawla wa la quwwata illa bika ya arhamar rahimin. Allahumma stawda'na kama 'allamtanahu fartudhu ilayna 'inda hajatina ilayhi wa la tansanahu ya rabbal alamin. Sallallahu alaihi sayyidina Muhammad wa ala alihi wa sahbihi wa sallam walhamdulillahi rabbil alamin.
Amin ya rabbal alamin. Shukran Ustaz.
Afwan.
Okay, we skip something. Still review for final. My plan was to do last class simplex, but I think we skip that. Let's do transport for today, transportations. Okay, we do just have a warm up on transportations. It's from the textbook, question 5. Consider the following minimum cost transportation problem. Of course, in transportation, mostly we look for minimizations. This is, you are given here 3 origins: origin 1, origin 2, origin 3, destination 1, destination 2, destination 3. So we have the demand from the destination 1, 150, destination 2, 200, destination 3, 150, and then supply from origin 1, 250, origin 2, 150, origin 3, 100. This is the cost per unit to transport from each route. Now the question is, use minimum cost method to find an initial feasible solution. Okay. Let's answer A first. So before answering, I think you have to copy this tableau, maybe something like this. Okay, try to copy this one quickly, unless you have your template with you. You don't have your template, you copy quickly. In exam, you have to write this one. I hope you're doing it. Maybe you don't have to write destination, just D1, D2, D3, supply, O1, O2, O3, demand, that's sufficient. You are done. If you are done, please shout done.
Done, sir.
Okay, good. I assume everybody is done. Okay, look back at the question. Let's look back at the question. use minimum cost method. Minimum cost method to find an initial solution. Minimum cost method. What do we do to find initial solution? What should we do? Look at the cost, right? Look at the cost, then look at the minimum cost first. What's the minimum cost amongst all these? 6. 6 the minimum cost, and then origin 1 can supply 250, and demand destination 1 require 150. So we are going to use the minimum cost first. So how many units are you going to transport along this route or this cell? Demand
150.
150. So as many as possible, 150. Then we cannot do this one anymore. All use up. If you want to do X, use in pencil. We are going to use that space again. And then the next least cost, which one? 6. The next least
8.
cost, 8. This 8 cannot use. So we have 2, 8. I think take the nearer one first. You can use this one or this one. I think for our purpose, I use this one. How many units are we going to transport along this route?
100.
100. 100. So 100. Now origin 1 cannot supply to this one, already used up. And then the next least cost,
10.
10. So how many units are we going to transport here? Origin 3 can supply 100, and then demand 150. 100. So supply, we can supply 100. And then the next least cost, we have 212 here. 14. Can we supply anything from here? All used up already, right? Here cannot. So we have this 12. The next least cost. How many units are you going to transport along this route? 100. 100. Now we are left with one cell. How many units are we going to transport here?
50.
50. 50. Okay, so this is our initial solution. I clear this one. We are going to use this space. So this is our initial solution. If you are required to calculate, then you have calculate the cost and then the route. If you are asked to state. So I think for us, we don't have to spend time on that. So the initial solution, origin 1 to destination 1 with 150, origin 1 to destination 2, 100, origin 2 to destination 2, 100, origin 2 to destination 3, 50, origin 3 to destination 3, 100. You don't worry about this little 1, 2, 3. This is the sequence for my own reference. Now, what should we do? We have to check m plus n minus 1 must equal number of basic cells. M plus n minus 1. Number of origin plus number of destination. M number of origin plus n number of destination minus 1. What do you get? 3 plus 3 minus 1. What do you get?
5.
5. Sorry to ask this little too simple question. Now, how many basic cells do we have?
5.
5. So now if you were to find optimal solution, now to answer question 2, yeah, use transportation simplex method to find an optimal solution. Can we proceed? The condition is M plus N must equal number of basic cell. If it is not, then you have to create artificial flow. How to create artificial flow? Put 0. 0 is an artificial flow. Anywhere, or if you use this one. If not, you can use this one, or you can use anywhere. Which one? Only 1 0 to make it equal to M plus N minus 1. In this case, we are okay. So the next thing we have to find, what do we call? Auxiliary index, U and V. We are going to find U for row 1, row 2, row 3, and then V for column 1, column 2, column 3. So what do we do? Look at the basic cells. Look at the basic cells. These are the basic cells, or use root or allocated cells. Some use allocated cells, some use basic cell, some use allocated root. So we are going to use UI plus VJ, UI plus VJ, U1, U row 1 plus V column 1 equal CIJ, 6. Then do we have any more here? This is also basic cells. We are looking at basic cell.
U1 plus
U1
V2
plus V2 equals 8. Okay, you write on separate part of your paper. And then we have another one, row number 2, U2 plus V column 2.
U2 plus V2 equals to 12.
U2 plus V2 equals 12. And then we have U2 plus V3.
2 plus V3 equals to 14.
Equals to 14. And then we have row number 3, U3
U3 plus V3 equals
plus
to
V3
10.
equals to 10. And we are going to find the value of U1, U2, U3, V1, V2, V3. Now we have 5 equations, 6 variables. It's not possible to solve simultaneously. So we do some mathematical trick. So just cheat the mathematics. Let U1, in normal practice, U1 equals 0. Just repeating what we have done. U1 equals 0. If U1 is 0, can you find V1? Very easy, right?
6.
So V1 is 6. The same thing, we can find V2.
V2 is 8.
V2 is 8. Now we know V2.
U2 4.
So U2 is 4. We know U2 is 4 from here.
V3 is 10.
V3 is 10. And then if we know V3
U3
is 10,
0.
U3 is 0. So now write down here in this table, U1, 0, U2, 4, U3, 0, V1, 6, V2, 8, V3, 10. And then what do we do next? We are going to look into these non-basic cells, unused root. So we are going to find the improvement index, which root or which cell is the best to use first. So how to find the improvement index? Remember, EIJ
EIJ minus
CIJ minus UI
minus UI
minus
minus VJ.
VJ. Okay, now just do mental arithmetic. 8 minus 0 minus 10. What do you get?
-2.
-2. Look at this next unused root or non-basic cells. 18 Cij, C row 2, column 1, minus U2 minus V1. 18 minus 4 minus 6. 8. How about this one? 8
2.
minus 0, you get 2. This one, brother?
4.
4.
4. What does it tell you? Optimal or not optimal?
Not yet.
Not
Not
yet.
optimal.
How do you know? To be optimal,
-2.
Eij should be greater or equal to 0. In this
0.
case, we don't satisfy this requirement. So not optimal. So if not optimal, we are going to draw closed path, or some say closed loop, L-O-O-P, loop, closed path. So how to draw the closed path? We're going to set at the most negative improvement index. Where's the most negative?
-2.
-2. So we are going to start our closed path from here. Then start, after that, from non-basic cell to basic, 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 and then close. If I were to come down here, can I come here and then close back?
Yes.
Yeah.
No.
No,
Oh, no.
because
Sorry.
because here is non-basic cell. What if I come here, then I move to this side, move to here, and then close? Is it possible?
Yes.
Possible. Okay, let's draw the closed path from non-basic. Let's say do clockwise. One minute. Oh. We're going to draw close path from non-basic cells here to basic cell. Then go to the next basic cell. Go to the next basic cell. Then close. Then what do we put here? What are we going to do? Add or subtract?
Plus.
Add. So non-basic, add, subtract.
Subtract. Add.
Then add,
Subtract.
subtract. So what we are going, how much are we going to subtract? We have two numbers here. One is 50, the other one is 100.
15.
50.
50.
Yes, 50.
We choose the minimum. So now how to do that? So we have to redraw the tableau. I think draw again. Draw one more, empty like this. But still, you have to, if you don't want to put D1, D2, D3, doesn't matter. But the cost you have to write down unless you remember, you can refer back to your upper table. I think one more will be sufficient. I think this is the last one. Okay, draw the table. Once you are done, and then shout. I repeat, in exam, you have to draw. Just telling you a story. Long ago, we give template. Some students do not know how to use. After that, become standardized. No template. Okay. Oh, I hope you are almost done. Are you almost done? I think so. Or you are finishing it off. Okay. Done?
Done, sir.
All right. I say done. Okay, let's look back at the earlier table. This is what we have done. So we are going to add how many units here? We are good
50.
50. You forget about this
50.
negative too, 50. So we are going to put 50 unit here, 50. Right? And then we subtract 50 from 50, right? Subtract
0.
50 from 50, 0. So in 0 means artificial flow. So we leave it blank. So we leave it blank. And then the next one, just look back at the upper table. In here, we are going to add 50, add 50 to 100.
150.
150. So write down 150. Here remain blank. Here 150. And then here, I'm flashing back the earlier the upper table. Subtract 50 from 100.
50.
50. So write down 50. And then the others, like this one, 150,
Copy
100, just copy back, not touched by the closed loop, just copy back. So 150, and here was 100. So this is your second tableau. You will see something like this. And then the same thing, we are going to find U, UI, and VJ. UI and VJ. Okay, can you just tell me which one? What? U1?
U1 plus V1 equals to 6.
U1 plus V1 equal to 6.
U1 plus V2 equals to 8.
U1 plus V2, right? V2 or V3? V2. U1 plus V2 is to 8.
Equals
And
to
then
8.
U1 plus
U1 plus
V3
V3 equals to 8.
equal to 8 also.
All the same.
All the same. Then U2, because we are looking at this one.
U2 plus V2 equals 12.
To 12. And then we have one more. U3
U3 plus
plus
V3
V3 equal to 10. Okay, we have 5 sets of equations because there are 5 basic cells. Then now we are going to find U1, U2, U3, V1, V2, V3. Normal practice, U1, we make it equal 0. U1 equals 0.
V1 equal to 6, V2 equals to 8, V3
V1,
equals to 8.
V1 equal to 6, V2 equals to 8 because here is
V3
0,
equals to 8.
V3 is 8. Now we have this V2, you can find
U2 equals to 4.
U2 is equal to 4. And then from here,
U3 equals to 2.
equal to 2. Then write down here. Yeah, 0, 4, 2, 0, 4, 2. 6, 8, 8, 6, 8, 8. Now let's find the improvement index at the non-basic cells. The improvement index here. So which one? Here. This is the earliest
8.
one. 18 minus 4 minus 6. 8. Brother gets 8. Then 14 minus 4 minus 8. 14 minus 4
2.
minus 8. 2. Fatihah say 2. Brother say 2. Then 8 minus 2 minus 6.
0.
0.
0. And then here 12 minus 2 minus 8.
2.
2.
Finally.
Finally, what was finally? Is it optimal? So optimal, right?
Yes.
Optimal. How do you know optimal? Eij is greater or equal to 0. Now, you notice one of this Eij equals 0. Eij equals 0. One of them equals 0. Do you notice anyone equals 0? This one, right? Do you see this one?
Yes.
Okay, what does this mean? It means that this is one solution that give you, okay, let's solve this one first. What is the total cost? So now your root will be O1 to D1, 150, O1 to D2, 150 is 50 units. Then O1 to D3, 50 units. Then O2 to D2, how many units? 150. O3 to D3, 100 units. What's the total? What's the cost? Total cost? Can someone compute?
4,500.
Total cost 4,500. Maybe it's dollars. So 4,500. Then you see one of this E improvement index is 0. That means there is more than one solution. That means we have an alternative optimal solution, not necessarily using this route, that give you the same cost. Okay, I think you are okay with this one. All right, let's move on.
Sir,
Yeah,
do we need to find the alternative solution?
you want to find, you can do, then use this as a starting point. Use this one, maybe you can draw the loop like that, like that, like that. Oh, cannot. Like that, like that, like that. You want to find, can, but I'm not prepared for that. So you start from here. So we are going to draw a closed loop from here to here. Then we cannot stop here because we, from here to here, say clockwise, we are going to go clockwise. I cannot stop here because if I were to come down, I cannot close. So I can just bypass this 50 and then come here, come down here and close. You want to do, then maybe on your own you can find. Then we have another line, that direction, another line in this direction, and then close, close. So the same thing here. What should I do at this point? Plus or minus? Plus. Plus. And here, alternately, minus, plus, minus. And then you do exactly the same procedure. And I think there'll be some quantity here. And it could be plus, minus, maybe 100 here. I think off the cuff, I can estimate here. Because this will move here, 100 move here, right? Are you following? 100 will move here. And this one become 50. This one become 150. And here nothing. Then you do again, you will get 0 here. Then you do again, and then we'll back to this one again. You will back to this solution again. So you get back and forth, back and forth. Are you following, Brother Ashraf?
Yes,
If you do, Sister Fatia, you are listening also. If this one move here, I think when you proceed, the improvement index at this point will be 0. 0, and here some, and then you will go back and forth, and the 100 will be here and here. So maybe the alternate solution, 100 will be here. You become, maybe someone try. Since I didn't, 100 times 8, whether you get 4,500 or not. 100 times 8 plus 50 times 6. Okay. Here become 150 times 8. Here nothing. Plus 50 times 8. This one. We haven't calculated this one. Plus 150 times 12. I think you will get 4,500.
Yes, the same.
The same. This is why I say we have more than one solution. Okay, this one I'm not doing it. I think the idea is to, for revision, you are okay, because I thought we do 2 iterations is sufficient because we had limited time. Okay, let's move on to what should I do? We do assignment problem. We do one assignment problem. Scott's and Associates Incorporated is an accounting firm that has 3 new clients. Project leaders will be assigned to the 3 clients. Based on the different backgrounds and experience of the leaders, the various leader-client assignments differ in terms of projected completion times. The possible assignment and the estimated completion times in days are given here. Use Hungarian method to obtain the optimal solution. So we have 3 clients, 3%. What does it mean? Oh, just now I also didn't ask you balance or not balance.
Balance assignment problem.
So we have a balance assignment problem. So you need this information. So this one can be done quickly. So we need this 1, 2, 3 jobs, 3%. 3 jobs, 3%. Okay, let's do what with Hungarian method. What is the first thing to do?
Row operation.
Let's do the row operations. We can do this simple 1, 2, 3 JES, as simple as that. Let's do the row operation together. Okay, can you draw this simple table? This one. Oh. This one, can you draw quickly? Row operations. Look at the row by row. This is the information I already reproduced here. Look at the row. Then how to do row operation? Find
Subtract the minimum.
minimum. Take the minimum. The minimum is 10. Subtract 10 from 10, 10 from 16, 10 from 32. So what do we
0,
do?
6,
0, 6,
22.
22. Okay, let's do it the second row. The second
0,
also 0. 22
8.
minus 8. I'm not calculating, I just rely on you.
40,
26.
26.
26, right? 26.
Yes.
26. Are you all following? The others only here.
Yes.
Yeah, okay. Now the third row, which one is the lowest?
22.
Yes.
22.
22.
And then
2,
2.
2.
And then here
12.
12.
12. So we are done with row operations. Okay, let's draw this one, another one. We are going to
Column
do
operation.
column operation. Column operations. Let's look at the column 1. 0 minus 0, everything 0. So 0,
Yes.
0, 0. Now column 2.
2.
2 is the
4,
lowest. So 0,
2,
okay, 2.
0, 6, 4.
Again, 2 is the lowest. 6,
6,
4.
4.
Okay. Right now, the other one here is the
12.
12. So let's put 12 minus 12,
0,
0.
0.
26 minus 12,
14.
14.
14,
10.
22, 10. 10 is it? 22 minus
Yes.
12, 10.
Yes.
Okay, what's next? Draw.
Draw line.
Draw lines. Draw minimum number of lines that crosses the zeros, vertical or horizontal line. So which one do you want to start first? Can we take this one downward and then zoom?
Yes.
Okay. Let's draw this line. One, go down. Oop, not straight. Okay. Is it optimal or not?
Not yet.
How do you know optimal? To be optimal, the
M
number
plus M minus 2.
no,
Minus
to be optimal, the number of lines to be optimal, because we cannot draw any more line here. To be optimal, the number of lines must equal number of row or number of column. Now, how many rows do we have?
3.
3 rows. How many lines?
2.
How many lines? 2.
2.
So it's not
We need one
equal.
more.
We need one more. So what do? We have to
We
do
need
some
one more.
adjustment. Remember,
Adjustment.
I call it to make simple adjustment. Okay, let's do some adjustment. You draw this one more time. How to do the adjustment?
Choose the minimum
Look at
uncovered element.
look at the remaining uncovered. I say uncovered, not crossed by the line. Look at the minimum. Then subtract all this globally. That means all over by the minimum. What's the minimum here?
4.
4. So subtract 4 from all these uncovered numbers. Okay, let's do one by one. So 4 minus 4, 0.
0.
0.
6 minus 4,
2.
2.
2.
And then 10 minus 4,
6.
6. 14 minus 4,
10.
10.
10.
Okay. Now what are we going to do with this number at the intersection of the lines?
Change to the minimum number.
we are going to add whatever number here. If there's number 1, add the minimum number. Here is 0, add the minimum number, become 4 plus 0. What do you get?
4.
4. This is very easy. 4. Then the others, no change. The others, 0, 0, no change. The one crossed by single line, no change, remain the same. And then what? Draw line again. Right?
Yes.
Draw line again. Now, which way do you like? You can draw this way, this way, this way, or this way, whichever. Which one do you want? The first one, the first 0, how do you like to cross? Horizontal or vertical?
Horizontal.
Horizontal. Okay, it doesn't matter. You can try other way you like to. Horizontal. And then you have this
Vertical.
vertical to hit the other 0.
Horizontal.
Vertical. And then horizontal. Okay, how many
Optimal.
lines? Optimal. How many lines do you have?
3.
3 lines. 3 lines. 3 lines. How many columns do you have? 3.
3.
So the number of lines equal number of rows or number of columns. So we reach optimality. So once optimal, what do? Start assigning, right? Start
Yes.
assigning. So now one job, one person, one job. Which one do you want to assign first? Look at.
At least do client number 1.
So at least do number 1. Because one job, one person, one job. At least do client 1, assign this one. No, he cannot do. One person, one job, cannot do this one.
Jackson do number 2.
Jackson do number 2. Or this one person, this job, only one person. Also okay, whichever way. All these are logical. Number 2, once number 2 cannot do this job. And then
Smith will do number 3.
Number 3. So the assignment will be Jackson to number 2,
number 1.
Alice to number 1, and Smith number 3. Total time in this. So we are going to take this total time. Alice number 1 plus 16 plus 34. So here you already get the answer. 64, 16, 14, 34. So you get 64. So this is the answer. Okay. Now which one to do? I was worried we don't have sufficient time. Okay, we do simulation first. Let's try one simulation. And then after the, I think we have time to do sensitivity study, sensitivity analysis. Okay, this company, to generate new leads for new business, Gustin Investment Services offer free financial planning seminar at major hotels in Southwest Florida. Attendance is limited to 25 individuals per seminar. Each seminar costs Gustin 3,500, and the average first-year commission for each new account open is 5,000. That means if there is someone signing up, one person sign up, you get commission of 5,000. So if we conduct seminar, it costs 3,500. If nobody sign up, it costs 3,500. If one person sign up, he get 5,000. Maybe so he get profit of 1,500. If he get more than 1% per seminar, 2% get 10,000, and then his cost still 3,500. One seminar, 3,500. And then during the seminar, he signed up, say 2%, he get 10,000. So he get a profit of 6,500. Okay, the story goes, historical data collected over the past 4 years show that the number of new accounts opened at a seminar varies from nobody signing up, no accounts, to a maximum of 6 accounts open, according to the following probability distribution. So he has collected some information, maybe how many, 4 years, maybe a lot of data. There are 0.1 probability, nobody sign up. 0.01 probability, nobody sign up. Are we getting the story first before I proceed? Okay, 0.04 probability, 1 person sign up. 0.1 probability, 2 person sign up. 0.25, 3 person sign up, and 3 new account. 0.4 probability of getting 4 person signing up or new account. 0.15, 5 sign up. 0.05, 6 sign up. So now set up intervals of random numbers that can be used to simulate the number of new accounts opened at a seminar. So what do we do? What is the probability of getting 0 new account? What is the probability?
0.01.
0.01. Let's write down here. What is the probability of getting 1 or less? 1 or less?
0.05.
0.05. You're actually working on the cumulative probability. So we are actually doing the cumulative probability. Then what is the probability of getting 3 or where am I? 2 or less?
0.15.
So that means 0.1 plus 0.04, 0.01, 0.15. Okay, how about 3 or less?
0.4.
0.4. Everybody following? How do we get this number? We are working on the cumulative probability. 4 or less, that means this one, add up all this. 4 or less?
0.8.
0.8. 5 or less?
0.95.
0.95. Then 6, from the analysis, 6?
1.
1. So we already answer, set up intervals or random numbers that can be used to simulate the number of new accounts opened at a seminar. Then how are we going to simulate? Here, use the first 10 random numbers in column 9 of table 12.2. I will show afterwards. Simulate the number of new accounts opened for the 10 seminar. Use the first 10 random numbers in column 9. Okay, this is the random numbers. The random numbers. Use the first 10 of column 9. Column 1, column 2, column 3, column 4, column 5. So this is actually the table, column 5, column 6, 7, 8, 9. Then use the first 10 to simulate the first 10. Okay, let's do back at the questions. Set up, use the first 10 random numbers in column 9 of table 12.2. Simulate the number of new accounts open for 10 seminars. So we want to imagine if we are going to open 10 seminars, what will happen? So we are going to use the first 10. So the first 10, this is the 10 we are going to use. Then let's do the simulation. Let's do the 10. I enlarge this for you. And we are going to use back this informations. This one. And we're going to align this with the number of accounts open. The probability, and we are going to get this. We are going to align this. So this is the cumulative probability that we get. I reproduce here. And then this is the accounts open. 0.1, that means 0 account, 0.5, 1, 0.15, 2, 0.4, and so on. So these are the random numbers which we generate from the table. You can use computer if you want to. Now, the first number is 0.7169. 0.7169. Where does it fall? Somewhere here, right? Look at the cumulative number. That means less than 0.8. Above 0.4. So how many accounts do you get? It is, we are imagining we are going to have 10 seminars. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The first seminar, based on randomly generated number, this is the probability. Somewhere, it falls somewhere in this range. So we may get how many clients signing up? How many? 3. So let's put 3. Align this 3. And then the second one, second number, 0.21, 0.21, somewhere in here, right? So 2. So maybe next seminar, maybe we get 2 persons signing up. Then the next one, the third seminar, what's the likelihood of getting
Also 2.
customer? Also 2. Then the fourth seminar, 0.91.
4.
You can get 4. And then the fifth seminar, 0.11, somewhere here. So we get
1.
1. Then the sixth one, 0.98. Wow. Somewhere here, right? So how many?
5.
New? 5. And the same thing, 0.5, yeah, 3. I think you get the idea already.
3.
0.4 is 3. 0.78, also 3. 0.07. Oh, luckily, I thought 0.
1.
1. Okay. Now, if he were to do another 10 seminars, this will be the participants. And how many total participants? How many new account signing up? You add this number. How many of this? 3 plus 2 plus 2 plus 4 plus 1 plus 5 plus 3 plus 3 plus 3 plus 1. Get 20?
7.
27.
27.
Okay, now look back at the question. The question is, it costs each seminar 3,005. And then it's each new account, he get 5,000 commissions. Now you have done this one. You have done question B. You have simulate 10 seminar. Now, what's your advice to Gustin, whether to run the seminar or forget about it? Okay, look back. It costs 3,005 each seminar. For 10 seminar, how is the total cost? Remember 10, 3,005 per seminar, and then the 5,000 commission for each new client. What is the total cost for 10 seminar? 10 times 3,005, right? Total cost? Come on.
35,000.
35,000, yes. And then he get 27 new, the chances he get 27 new account. And each of these will get commission of 5,000. So what is the total commission he get?
27
27 times 5.
5,000.
135, right?
Yes.
135,000. So what's the questions? What's your advice? Whether should proceed with the seminar or not? Does he make profit or not? What's the profit?
Yes.
Profit is
Revenue minus cost.
revenue minus cost. So this is the commission he get. This is the cost for the 10 seminar. This is the revenue.
So large.
Huh? Yeah. So where will be the profit he get?
100,000.
100. So what is your advice to Gasin? Proceed or not
Do the
proceed?
seminar.
Do the
Proceed with the
seminar.
seminar.
Okay. You get the idea? Everybody get the idea? This is how we simulate situations. Of course, you can use computer to generate this number. Okay.
Sir, sorry.
Yeah. Yeah.
Where to get the 10 random numbers?
Yeah. Just now we get. Oh. Let me show. This one. The question say, okay, let's look back at the question. The question say, using the first 10 random numbers in column 9. Look at the question. Use the first 10 random in column 9, simulate the number of accounts. So this is column 9, and I get the first 10 numbers, and I enlarge it here. Enlarge here, and this is what we are doing. So this is the simulated new account. That means if you keep continuing, you still get more money. You continue 10 seminar, then you get 100,000 clean. Because this is the cost, total cost. This is total commission. This cost per seminar, cost the commission per new account. Okay. Any more question? No question. Okay. I think we have time. Can we do sensitivity study? I think simplex, we don't have time. Or you want to do simplex?
It's quite long.
Quite long. I think I do sensitivity is easier. It's take quite short. Let's do simplex based sensitivity. This is using what we did in linear programming in graphical method. You remember in graphical method, RMC
Yes.
problem. So this is actually the formulation. I don't have to write. Okay, maybe just read quickly. Recall the RMC problem that we did before. The problem is shown here. So we already get the formulation. And then we also have the final, assume you do simplex. This is the final tableau. The final tableau. Now, calculate the range of optimality for C1 and C2. I think we do 1 is sufficient because C2 will be the same. So compute the range of optimality for C1. What does it mean? Let me want to know what will happen to this profit. This is C1, C2. If we look into this one, this is the final tableau C1, C2, C1, C2, C3, C4, C5. So now we do just 1 is sufficient for now. How do we do? Compute the range of optimality for C1. Okay, let's do the first one. You need this information. You may not need this one for now, for this one, but for the next question, you need this one. And you need this information. Okay, let's do this one first. So what do? Try to reproduce the table. This is the final simplex tableau. We are going to change this. We are going to find C1. C means range of optimality for column 1. We are going to change this, and we are going to recalculate all this Z value and Cj minus Zj value. Okay, let's do range of optimality C1, and maybe you have to reproduce this. I think you can reflect back the question. You don't have, you can just put a piece of paper down here, somewhere down here, but never mind. For this class, I suggest you copy this so that you have some idea how to do it. So we are going to change this 40 into something, C1. So we are going to write C1. So we are going to write C1 here. C1. One at a time. That means if you change this one had to retain. If you change this one, you have to put back 40. If you change C1, the coefficient of X1 also change. So
C1.
this one becomes C1 also. Okay, you do this one first. I give you about 2 minutes, 1 minute. Oh, you are done already. We are just copying these informations. Except that you change.
Z1 is C1.
Yeah, I just want to know, everybody done this one? This table? Okay,
Oh,
so not yet. Okay, can we proceed? Done? Done on doing this one, table?
Yes, sir.
Okay.
Yes.
So now let's calculate Z. Just now brother was saying C1 over here. What do you get here? 30 minus 0 plus 0 times 0. C1 times 1, you get C1.
C1.
Here, this side, get
30.
30. And here you see the common denominator. look at this 0, so we are not going to use this. Here common denominator is 3. So 30 times 10, 300/3 plus C1 times -5. So
100 minus 5/3 C1.
100 minus 5C/3, right? Is it the same? This common denominator. Agree with this one?
Yes.
And then here, 0
0.
over here. Negative
Negative
30 times 20, 600
plus
over 9
25 C1 over 9.
over 9. Okay, we do this one. So we have Zj. Find Cj minus Zj. C minus C, 0.
0.
30 minus 30 is 0.
0.
0 minus this one, the sign will change. Negative 30
5
to
C1 minus
5C1
300
minus
over
300.
3.
Okay. Here?
0.
0. And here the sign will change. 0
600
minus
minus
600 minus
25 C1 over
25 over 9. Okay. So we are done up to this point. So now we want to know the range of optimality. Let me put red pen again. So we have, look at Cj minus Zj. Cj minus Zj, we are interested at C. So we have 2 here. So let's take one of them. Minus 300 plus 5
C1
over
over
3. To be optimal, what's the condition?
less than or equal to more than or equal to 0.
It's maximization.
Oh, sorry. Less
Uh,
than or equal to 0.
Less or equal to 0. Now less or equal to 0. So it should be less or equal to 0. Let's use the other one. Plus 600 minus 25 C1 over 9.
Over 9 less
To be
than or equal to
optimal,
0.
should be less or equal to 0. So now we have this one. So 3, if I were to throw that side, it will disappear, right?
Yes.
The same thing here. If I were to throw to the other side, this will disappear. So now I have negative 300 plus 5C1 should be less or equal to 0. And then this side, 600 minus 25 C1 should be less or equal to 0. Now can we put C1 at one point? So can I have here C1 should be less or equal to?
C1 less than
6.
or equal to 60.
300 minus 5 right? Equals to 60. Okay, you get 60. Now I want to throw
This
this
one will be C1.
C1 I put on
C1
the
is
right
greater
hand,
than 24.
greater than 24. So 600 over 25 equals to, sister say 24. Now let's put
More
C1.
than or equal to 24.
Let's C1. Okay, what's the upper bound? What's the lower bound?
Upper bound
Bound
is
is
60.
60 and lower bound is 24.
Upper bound 60, lower bound is 24.
24.
Okay. 24. Let's look at the questions. So we are done with C1. Suppose that there is an increase in the production cost, the profit per ton of field additive is X1, is reduced to 30 per ton. What effect will this change on the optimal solution? Okay, 30. If C1 is 30, will this solution remain optimal? Will this solution remain optimal?
Yes.
Yes. That means
Yes, because
no.
it's within the range.
That means within the range, remain optimal. So we already answered this one. What is the dual price for constraint one? Okay, how to know this? The dual price actually is this value of Z. This is for material 1, material 2, material 3. So 100 divided by 3 is the dual price for material 1. What is the interpretation? That means you may have some profit, but there is some cost also. Maybe the factory floor charge you costs. So you may get profit out of this 100 divided by 3, that means 33.33. If the factory floor charge you 40 ringgit or $40, I mean, not worth it. If they charge you maybe $10, it is okay. And then the next question here, if RMC had an opportunity to purchase additional material, which material would be the most valuable? Okay, now we have look at the slag value of Z for the slag. This is the dual price for material 1, material 2, material 3. Now, the question is, which one is the most valuable? Which one is more? 400 divided by 9. What do you get?
44.44.
44.44. Here 33.33. Here 0. Which one is most valuable?
44.
44.44. That means which material? Material 1, 2, 3?
3.
Material number 3. How much are you willing to pay for this material maximum?
44.44.
44.44. Okay, done with this. Let's do the next question. Now, compute the range of feasibility. Now, question 11. Compute the range of feasibility of, I just do one, because B1, B2, B3 is the same method. Compute the range of feasibility for B1. How to do this? So this is, so we reproduce this. You need this information. You need this information also, this information, and you also need this information. When you say B1, B1, that means material 1, B2, material 2, B3, material 3. Okay. Okay. Look at this. B1, material 1, B2, B3. B1, B2, B3. Now B1. How much can this go up? How much can this go down? Okay, let's do B1. Find the range of feasibility for B1. Find the range of feasibility for B1. It means we want to know this one. So how do we do? I think you may not remember the formula. Never mind. Look at this one, the arrangement x1, s2, x1. I rewrite here x1, s2, x1. Then look, what is the current solution? Write down the current solution. This is the current solution. 21, 25. 21, 25. Then we are going to multiply this with some amount of change for this one, B1. So the amount of change is delta B1. So plus delta B1, amount of change, up or down. And then multiply, since B1, material 1, multiply with the coefficient of the slack or surplus variable corresponding to this material 1. The coefficient of slack or surplus variable corresponding to material 1, P1. Which one? This one, second one, third one. This is the coefficient of the corresponding slack or surplus variable. Which one to use? This one, right?
S1.
S1. So we write down 10/3. We multiply 10/3, -2/3, and then -5/3.
-5/3.
And then to be optimal, not to be optimal, and then all right-hand side value cannot be less or equal to 0. Must be greater or equal to 0. So anything right-hand side value must be greater or equal to 0. So we write down greater or equal to 0, all of them. And now let's play the game. Now the game start. So we're going to write this way. The first one, 20 plus delta 20 plus 10/3 delta B1. Agree? And this one must be greater or equal to 0. Then you write another one, the second equations, 1 plus -2/3 delta B1. And all this must be greater or equal to 0. Then the third one, okay, can you suggest? 25
minus 5/3 delta B1
minus
greater than 0.
5/3 delta B1 greater than 0. Okay, so let's do this one. The first one, 10/3 delta B1 should be greater or equal to minus
more than or equal to 0. -20.
-20. Okay. The second one, 1 should be greater or equal to
more than or equal to
2/3
delta B1.
Okay, the third one, 25
more
should
than
be
or equal to 5/3 delta
5/3
B1.
delta B1. Okay, let's find the first one. The first one, delta B1.
B1 more than or equal to negative
60.
-6.
Negative 6 or 63? 6.
6.
Yeah.
6.
6.
The second one?
Second one is delta B is less than 3/2.
Delta B1 should be
more than
3/2.
3/2.
Okay, the third one, delta B1.
Delta
B1
more
less
than
than
or
15.
equal to 15.
15. 15.
Yeah. Yeah.
Yes.
15.
15. So now we have amount of change B1. Now we want to know the upper range, lower range. What's the upper range? We have two numbers, right?
15.
3/2 and 15.
15.
The lower range, only one.
The lower range is -6.
So now we have two upper bound. Which one to choose? Which one to choose? The upper
Maximum
bound,
one?
maximum.
Three over
Whenever we have more than upper bound, choose the lower value. Whenever we have more than one lower bound, take the greater value. So which one to choose?
3 over 2.
3 over
3
2.
over
So
2.
okay. So now this is actually the amount of change, but the original is 20. Take note here is 20. That means 20 can go up by 3 over 2, can go down by negative
Minus
6.
6.
Minus 6. So what's your, yeah, so now B become B1, not delta B1 anymore. This amount of change, 20 plus 3 over
3 over
2.
2.
Here 20, the original,
20
plus
minus 6.
negative 6. So here become 14.
14 less than or equal to
B1.
B1
Here
less than or
is
equal to 21 half.
21.5. Okay, good. That's how to handle sensitivity analysis. Actually, simple if you understand the concept. Okay, we are done. So we are ending our day. Let's. All right.
Doctor, how many questions will there be for the finals?
I cannot remember. Main question maybe 6 or 7. I'm not so sure. Will be comprehensive. I'm not so sure. I think I'm not privy to that information also.
But the timeline then, are we given a short time or is it going to be like a few hours before?
I think normal 3 hours.
3 hours.
Normally 3 hours for final. Okay, we want to conclude our day with Brother Ustaz Farhan will recite closing dua for our class. We are completing our course. Let's have a dua by Ustaz Farhan.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين وعلى آله وصحبه أجمعين سبحانك اللهم وبحمدك نشهد أن لا إله إلا أنت نستغفرك ونتوب إليك ربنا انفعنا بما علمتنا ربنا علمنا الذين ينفعنا ربنا فقهنا وفقه أهلنا وقرابات لنا في ديننا توسلنا بتعليم أن ترزقنا الواسع وأن ترزقنا الأمانة. Maha suci Engkau ya Allah. Segala sanjungan untukmu. Kami bersaksi bahawa tiada Tuhan selain Engkau. Kami memohon ampun-Mu dan kami bertaubat kepadamu. Ya Allah, berilah kami manfaat dari apa yang telah Engkau ajarkan kepada kami. Ya Allah, berilah kami pengetahuan terhadap apa yang bermanfaat bagi kami. Ya Allah, berilah pemahaman kepada kami dan kepada keluarga kami, para sahabat kami dalam memahami agama-Mu. Kami bertawassul dengan belajar, kami bertawassul dengan mengajar, agar Engkau beri kami rezeki yang luas dan agar Engkau beri kami rezeki amanah. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wasallam. Walhamdulillahi rabbil alamin.
Ya Rabbal Alamin. Okay, thank you very much, brothers, sisters. It has been great to be with you.
Thank you, Doctor.
Yeah, so
Thank you, Doctor.
you're most welcome.
Thank you, Doctor.
So,
Thank you, Doctor.
most welcome.
Thank you, Doctor. Thank you,
Yeah.
Doctor.
You're most welcome. All the best in
Thank
your
you,
final.
Doctor.
Yeah, most welcome.
Doctor, for the final, how many questions?
Yeah, just now Sister Sisri asked, I think 6, 7 like that. I'm not so sure. I have to check. I think I cannot.
Doctor, also one more
check.
thing. Are we supposed to submit the answer through iTalim or through your email for the final?
I don't have that answer yet. I don't have the answer. I may put in the group. And how are you going to do it also? I'm not so sure. I understand you have to scan it. After that, either pass to me or pass to the administrator. I'm not sure. Actually, I wanted to find out about the detail. I think the exam date already known, right? The exam date is already known.
22nd June.
22nd, yeah. So that thing I will let you know through the group, how to submit, how to handle all this thing. Okay, any other questions?
Okay, thank you, Doctor.
Yeah, most welcome. Okay, nice to have you around. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam, Doctor. Have a good day.
Yeah, same to you all.
Waalaikumsalam.
In the class now.